In this video, we're going to start to bring some analysis, some actual numbers in to vectors to define particular vectors a little bit more exactly. So in order to do this, I'm going to define position vectors and the vector components. So, all right, so let's say I have a point in the plane, v1, v2, so the x coordinate and y coordinate of the point. If I have a vector with tail at the origin, starts at the origin and terminates at the point v1, v2. So notice this is a point. I'm using parentheses here. Point. I use parentheses to describe that. And if I take, so I build the vector from the origin and this point, head at the origin, or tail at the origin, head at the point. This gives me a position vector. The position vector that's written v1, v2. So notice here I've used angle brackets. This is angle brackets, and we use these for vectors. So this is one thing you're going to get out of this class is you have to be very precise. Points are also specified by giving an x component and an x coordinate and a y coordinate. That tells me a point in the plane, but that's just a point. I use parentheses for that. If I want a vector whose tail is at the origin and head at the point v1, v2, I write that with the angle brackets, v1, v2. So this is a vector, this is a point in the plane. Very subtle, very important that you understand the difference between these two bits of notation. This is something students have struggled with in the past, and it is because it's very subtle. It makes sense, but that's, again, one thing you need to get out of this class is being very precise with your notation, precision. So when we're talking about a vector, so here these are the coordinates. So this is the x coordinate of a point and the y coordinate of the point. When we're talking about a vector, we're talking about the components. This is the x component, and this is the y component. v2 is the y component. Components compared to coordinates, points compared to vectors. What's nice is if I'm just talking about position vectors, so these are ones with tail at the origin, head at some point. Two position vectors are equal if and only if their components, each of their components is the same as the other one. u1 equals v1, u2 equals v2. So that is if I have two position vectors, u1, u2, and v1, v2. These two things are equal if and only if each of the components are equal. All right. So what do we do with this? Well, let's actually look at an example here. So given a position vector v equals v1, v2, so I'm going to actually pick a particular position vector here. I'm going to say let's let v be, how about 2, -1. What this means is, let me draw some things here. 1, 2, 1, 2, 1, 2, 1, 2. So this is my x direction. This is my y direction. I plot the point 2, -1, so 2 in the x, down 1 in the y. So this is the point, 2, -1. And then if I draw a vector with tail at the origin and head at the point 2, 1, this is the vector 2, -1, is that vector. This is a position vector because its tail is at the origin, but notice there's infinitely many vectors that are equal to 2, -1. While that's the position vector, this is also v over here. I'm not going to call this 2, -1. I'm going to call this v. So v is 2, -1. This is v here. Let me copy this one. V is the same there. These are all 2, -1. These are all the same exact vector. It doesn't matter where I put this vector, as long as it has the same direction and magnitude, it is also v. In this case, direction and magnitude is specified by these components, over 2, down 1. These are all the same vector. This vector here that I've drawn is the position vector, 2, -1. All right. So one thing we've been doing is we use this notation PQ if I have 2 points in the plane. So let's say P is here. And let's say this is x1, y1. I'm not going to actually give values to these. I'm just going to use variables. So let's say this point is at x1, y1. And let's say this point here is at x2, y2. Then the point, so this is P, this is Q. I can draw the vector between them. We know this is called PQ. And what if I want the position vector for this vector PQ? So that is, if I take PQ and I form the position vector, so I take its tail and put it at the origin, where is its head? So how do I write PQ in terms of components? So PQ, I want to say, is equal to some x component, some y component, like this. How do I figure that out? Well, I need to figure out where this point is relative to the origin. Well, how do I do that? Well, I need to look at Q relative to P. I need to know how much it goes over and how much it goes up. So how much it goes over, this is the difference between the x values. So this distance here is x2 minus x1. This distance here is y2 minus y1. And what that means is then if I take the tail of PQ, put it at the origin, that this point will be exactly x2 minus x1, y2 minus y1. So I've now found the point that would correspond to that. And so I have the components of the position vector corresponding to PQ. It's exactly x2 minus x1, y2 minus y1. So this is going to be really handy. Again, I can have a vector anywhere in the plane. If I measure how much it goes up, how much it goes over, that tells me the position vector for it. So it's sort of a way to standardize vectors where we put the tail at the origin and head at some point. And now we have a way to represent it with numbers. All right, that's it for this video. I'll see you next time.